Hello, let me make a short video and we'll go over the homework for homework 2. So the first part here, we had to calculate the average values of the pulses shown. So let me enlarge this a little bit. So we'll start with A here, and let me bring this over here. So with A, the period is 10 milliseconds, and then the duty cycle is the pulse width divided by the period. So it's high, or the pulse is 2.5 milliseconds wide, and divided by 10 milliseconds, that gives us a duty cycle of 0.250. Then the VPP is the high voltage is 40 volts, or the max, minus the minimum, which is -20. So 40 minus 20 equals 60 volts. Then the average voltage equals the minimum, or the baseline, plus the duty cycle times the VPP, and -20 volts plus 0.25 times 60 equals -5 volts. All right? And then B, so B is here. We have the pulse width is 250 microseconds. The time, or the period, is 1 millisecond. So if we take, and let me clear this, 250 milliseconds let me back up. Microseconds is -6, and then we want to divide that by 1 millisecond. Hold on, I am doing this wrong. It's 250 exponent -6 divided by 1 exponent -3, it equals 0.250, right? So it's the same duty cycle as the first problem. And then the VPP is 9 volts minus a -3, which gets us a total of 12 volts. And then the V average equals the baseline, which is -3 volts, plus 0.25 times 12, and that comes out to 0 volts. And then the C, the period is 400 microseconds. The pulse width is 200 microseconds. So 200 over 400 is 0.5. VPP is 40 volts minus 0 volts is 40 volts. And then the baseline is 0 volts plus 0.5 times 40 volts. So the average voltage is 20 volts. And then this fourth one, D, this one's a little trickier because it doesn't show us the pulse width here. It shows us the pulse width here is when it's at the lowest point. So the PW here, I mean, I guess you could do it either way since it's showing the pulse width of 160, but normally the pulse width is where it's high. So it would be 200 minus 160, which would be 40 milliseconds. So the way I calculated it was the time equals 200 microseconds. The duty cycle equals the pulse width, which was 40, because it's 200 minus that 160, divided by 200 is 0.2. The VPP is 40 volts, so -40 volts is the baseline, plus 0.2 times 40 is the -32 volts. Now if you put 160 here, 160 divided by 200, and then take that times 40, I believe it's like -8 volts. And I'll give you credit for that too, because this document, or the image here, shows the pulse width of 160, even though it is always the high pulse width. So You really almost have to take the subtraction of the two. All right? So then the next part of this is calculate the instantaneous voltage. And this is really just a calculator question or a calculator problem. So all you have to do is take the 120 times the sine of the angle. So what I'm going to do here is clear this. So it's 120 milliamps times the sine, and then you can just put in of 0 volts or 0 degrees, and that's 0 amps. And then if I hit the up arrow or the right arrow and backspace, hold on. So it's going to be 120 exponent -3 sine, and then the next one is 45 degrees. And that equals 84.853 milliamps. And if I go here, and I'm just going to change that 45 to 90, and that's 120 milliamps. And if you just go all the way down using your calculator, just changing the angle, you'll get these values here. All right? And then finally, the last part is determining the period. So we know that the period is just 1 over the frequency. So if you take 1 over 60, you get 16.667 milliseconds. If you take 1 over 1000 or 1 kilohertz, you get 1 millisecond. If you take 250 kilohertz, 1 over that, you get 4 microseconds. If you take 102.7 megahertz, which is 10 to the 6th, you get 9.737 nanoseconds. If you take 1.8 gigahertz, which is 10 to the 9th, 1 over that, you get 555.556 picoseconds, which is 10 to the -12. All right? So that is how you do homework number 2. And let me know if you have any questions. Let me show you. Here's the sheet with all the right answers on it. And you might have to zoom in on that to get those better. Let me see here. And again, on this problem here, if you calculate it for 160, I'll give you credit for that. If you calculate it for 40 microseconds, I'll give you credit for that too. All right, thank you, and I'll see you next time.